a session about the events surrounding late August 1981 when Mike announced this extraordinary theorem. And so, well, what's the beginning? So Bob is going to come up and talk in just a second, but to set the stage, I mentioned somewhere or other that Mike saw notes on Andrew Cassin's talks about Cassin handles in 1974. And then over the next 7 years, he thought about this and published a couple of papers in between. I think Bob's going to mention those. And eventually we got to August 81. And well, let me turn this over to Bob because he knows the whole story. More of the story.
Yeah, hi. So this is a grand experiment, I guess you might say. It's not clear how this session is going to proceed. I'm going to try to say a few sensible words, and we'll see what happens after that. First, let me say how delightful it's been this week to be engaged in this conference. Just wonderful for so many reasons to see old friends, make some new friends, see some good old mathematics and new mathematics. I confess, too great a fraction of it is going over my head, but at least you get a feel for it and how exciting and great it is. So the main, as Rob said, his point here is to try and recall some of the history and background of August 1981. This, by the way, is the introduction to the fundamental paper that resulted therefrom. But I think one should look at this with a bit of context, which in fact requires going back a few years before, in a sense to fill in a bit more on the years between that were covered last night. Last night we covered Mike's high school years and early college years, graduate school years, I guess. But there's that period from PhD to 1981, which deserves a few words. And so in that sense, well, I'm going to expand things a little bit. But also I want to introduce a secondary context to think about as this goes on. Who was Mike as a mathematician back in those pre-1981 days? And at the risk of stepping on my toes and saying something wrong, just consider this as a secondary issue, how careers of mathematicians, great ultimately mathematicians, take off. Some take off with a high slope and they're like rockets. And names that come to mind perhaps are Milner, whose undergraduate thesis at Princeton was already famous, and didn't he stay around at Princeton immediately? At any rate, he was doing great stuff right from the beginning. So Sullivan's name was known right from the get-go. Thurston, I would say, Donaldson with an incredible thesis. And then the other kind, which are harder to think examples of, aside from Mike, which is the reason I'm mentioning this, Gromov comes to mind. He was well known before his great work, but it wasn't until he got his PhD in 70 or 71. He was well known for H principle and some other stuff, but it wasn't until the polynomial growth theorem 10 years later after his PhD that his star was. Well, I would, with Mike, I mean, he was just one of us. He was an ordinary, hard-working topologist in the 1970s, and it wasn't until 81 that, wow, okay. So, a bit of history from my point of view. I first met Mike when he was a last year graduate student, Princeton, 1972, in the fall. I had been there 3 years earlier, 69, 70, as a postdoc, and then after that I got a job at UCLA, thanks to Rob, and there you can get eligible for a sabbatical after 6 quarters, that is 2 years of teaching. So I decided to take my first sabbatical in the fall of 1972 back at Princeton, even though it was kind of overpowering to go there. I mean, you really have to be not afraid to be humbled when you talk to various people, go to various seminars at Princeton. But it was a wise move. In fact, mathematically, it paid off for me. But as part of that, I met Mike as one of the many graduate students there. I realized one reason, after Frank was talking, why I didn't see more of him, and that was because he was spending all his time over with Frank at the Institute for Advanced Study, I gather. At any rate, we didn't have any mathematical contact to speak of at that point. I was pleasantly surprised the following year when I got a visiting position here at Berkeley to teach in the fall, to see that Mike was there at Berkeley, having accepted his first job as an instructor here. So, got to know him a little bit better then. But again, no significant mathematical direct contact, but at that point, somewhere came my first indirect contact. I was given a manuscript that Mike had written to take a look at. I was asked to take a look at it by somebody. It was probably Rob, but it could have been somebody else. Almost certain it was Rob, though. And it was, I've forgotten almost all the details on this paper, but it was, let's say it was on four manifolds, and it was trying to, say, represent homology classes and simply connected four manifolds by maybe embedded S2s or something. Do you remember this manuscript? Okay. Okay, well, it was sort of tentatively written, but it claims and theorems. And I spent some time looking at it, and okay, this point made sense, and that point made sense. And then suddenly, at some point, there was this huge leap. Some mathematics from some distant world that I dimly knew was being invoked. And I didn't know much about the mathematics being invoked, but it sure seemed clear to me that there wasn't a link there, that this was just some speculative new ingredient thrown into the pot. I mean, this is my distant recollection. At any rate, I turned this back and I said, well, to me, this mathematics is, I don't know, it's fearless and it's daring, but gee, it's just, you know, a tad reckless. At any rate, I don't know what happened to the paper, but that was my first impression of my, okay, jumping forward. So 1978, and this is mentioned in the paper here, I'm going to try to find a point where Mike went back to Casson handles and made his first fundamental advance, which resulted in this S3 cross R paper, which has been alluded to, 1978, I'll call it, which is when the work was done. 1979 it was published. And Mike, as he says in the paper, in fact, came by and explained to me some of the details. And I had a reason to be interested because it turns out Richie Miller was at UCLA that year, and he and I were working on four manifolds and links. And we were trying to show what couldn't happen, exactly what Mike showed did happen, it turned out in the end. We in effect, were trying to show that the Casson handle couldn't be re-embedded in a finite stage. I mean, we were really working on a variant of that, but that in effect is what we were trying to show. So when Mike showed me his result that in the first 6 stages, say, of a Casson handle, he could embed a more complicated Casson handle. That was both a disappointment, it shot down Richie Miller's in my program, but also I was pleased that summer was coming and I didn't want this program to have to continue.
So why were you working on re-embedding with Richie Miller?
Well, we weren't directly working on Casson handles. We were playing around with iterated links, which were like Casson handles, and trying to show that, come up with some invariant that his work shot down. Anyway, I was somewhat relieved that I didn't really want to spend the summer thinking about this project with Mike's work. I wanted other things. So let's jump to 1981, but not to August yet. Yeah.
Just chronologically, the remark I would make here is that it seemed to me there were 2 or 3 occasions, maybe just 2, and I think Bob was mentioning one of them, where Mike told me that he had done something having to do with Dyson handles and 4 manifolds. And Mike told me about something he'd done, and that seemed very nice. And then the next step seemed so to go beyond that seemed so unlikely that I didn't pursue the issue. And then lo and behold, a year or two later, Mike went beyond that with another advance. So maybe the second time was this paper in the Annals. And again, there was a goal in sight, and once again, it seemed to me that progressing any further beyond where Mike had gone was again so unlikely that it wasn't a reasonable problem for me to spend my time on. And then of course Mike did it again. So I had this impression of 2 or 3 occasions in which I learned about what he was doing, and further progress just seemed so unlikely that I thought about other things instead. So that's, just thought I'd interject that.
I had lower opportunity costs.
Oh, I see.
Well, 1981, first let me mention January, only just to set the scene where Mike was at that point. I remember him giving a wonderful little talk at the AMS meeting, which that January was held in San Francisco. And what's his name? Saul was running a special session. And Mike gave a talk on, what was it, the conservative Dane's Lemma? He had a way of improving Dane's Lemma, which really tickled me. I've always been a fan of Dane's Lemma, and your addition to it was very nice. You were an associate professor by then. Just to get personal, I suspect it was the S3 cross R theorem was one of the major reasons you advanced to San Diego, but you were still immortal. Come April is the next little story I wanted to mention. So our last Southern California topology colloquium, where topologists from Los Angeles to San Diego get together, was being held that April. And I was going to drive down for the 3 o'clock beginning, planned to leave about 1:45. Usually that was plenty of time. Got held up by a staff search meeting. And then when I go out to the parking lot, it starts to rain, unusual in April. And it was a non-trivial rain, and it totally shut down traffic in Los Angeles and Orange County. And so finally I got down there instead of at 3 o'clock. It was about 6:15. After the seminar was over, and to make it more embarrassing, I had one of the speakers in the car. Bill Meeks was supposed to give the 4:30 talk. Well, I knew where dinner was going to be held, so I went there with my tail between my legs. Apologized to the organizers. We had a good dinner. And as we were exiting, Mike comes up to me and says, "Bob, where you been?" So stuck on the freeway, search meeting. Why? "Oh, I've been thinking again about Casson handles, and it turns out it looks like decompositions are entering the picture, and I wanted to talk to you about it." I said, "Oh, geez, well, no time then." And we went our separate ways, and nothing happened. Summer came, and now we go to August and talk about, as far as April goes, what if moments in your life. Well, whatever. August, yeah.
Can I interrupt? I'm pretty sure that April meeting,
Yeah.
so even though you arrived real late, you stayed for dinner with us, right?
Yeah, I was at dinner.
Yeah, so a very crucial thing happened at that dinner, which is that you showed the people at the table with this Andrews Rubin shrink.
Yeah.
Do you remember that?
I don't remember the incident.
Yeah, so in other words, there's this key example in point set topology
Yeah, in the middle here, Mike refers to a shrinking argument of Bob Edwards. And I thought that somewhere else here, yes, see this footnote 4. Something expounds Edwards' argument and serves as my take-home final in big topology. Thanks, Mike. So that's probably, this is relevant to what you were just saying.
Yeah, just a final comment before we get to August in San Diego, August in Cambridge. So that was one of those wonderful Cambridge summers we had back in the mid-70s to 80s. I was counting, we had 5 summers in a 10-summer stretch from 75 to 84, where Rob and Ray Lickwish would just say, hey, topologists, let's go to Cambridge. And somehow we managed to all get there and have a wonderful summer-long impromptu summer school experience. Good for all of us. Many people here in the audience remember those years, I'm sure. When are we going to do it again? At any rate, 81, it wrapped up. My family and I went on our final week's vacation in the car to Cornwall, Devon. Came back the night before flying. Taped to my door was this mail package from the U.S. This was before FedEx made it official and everything. I can't remember how it got there, but I was surprised to see it actually taped to the door. And it's some notes from Mike Freedman. Somewhere 10 to 15 pages of notes outlining his thoughts on proving that Casson handles are standard. And, okay, even there was a note there, call me when you get back to Los Angeles, we got to talk about this. Well, okay, so I look at these on the plane, and, well, I just couldn't put it together. I mean, well, there wasn't, I don't know if he's, well, I mean, there wasn't a clear proof, theorem, discussion, theorem, proof, discussion, whatever. You sort of had to fill in the blanks and whatever, and I just, to be honest, couldn't make much sense out of it. Got home, and I think Mike called me before I called him, and he says, you got to come down to San Diego early. So the point was, this coming week, the last full week of August, there was to be a CDMS conference at UC San Diego, must have been arranged by Mike, with Dennis Sullivan as the principal speaker. And it turned out to be an excellent conference. Dennis gave a wonderful series of 10 talks where, incidentally, he expounded on the hyperbolization theorem for 3 manifolds which fiber over a circle with pseudo and Asaf monodromy, which is necessary. Those talks were videotaped, in fact. At any rate, so I managed to get down there Sunday morning to Mike's house, and already there were some other people who Mike had invited to start off looking at his stuff early. Rick Ansell was there. I forget who else was there on Sunday. But I remember we struggled with it for some hours on Sunday. Okay, I mean, you know, it's at some point you have to decide whether to keep putting time into this or whether you just don't see enough of it making sense that you say, I don't know. But, you know, they look like, you know, definitely worth thinking about some more. So, I mean, me thinking about, Mike talking to us about it, explaining his ideas. Okay, so then let's go to the conference. Now, I can't remember when Mike got up to make his announcement of his talks. It was either Monday, later in the day, or Tuesday. It was, let's say it was Monday. And Mike says, you know, I think I've proved something rather significant. I forget what the words were there. And I've, in so many words, signed myself up to give 2 evening talks on this. Now this is at a conference where there are all these distinguished senior mathematicians. I mean, Rob was there. Bot was there. One of the old Grand Guard that I remember, and some others too. So this was quite a hefty crew that Mike was making this announcement that he was going to add 2 more hours to the already full week in the evenings to boot. Okay, so my reaction was, gee whiz, this is a ball's move. you really want to do this? This could be embarrassing. Well, okay, you know what? I mean, this is the perfect mic, right? So Tuesday, he gets up. Now, his arguments, we get into the argument, we won't get into details, although it'll be fun to review some of them, but ain't going to happen. So the main thing to appreciate here is that the argument has two independent parts. Both get into decompositions. The first part is, in a sense, the longer part in the paper. I think it's sections 2 through 8 or something. It's very technical manipulations within casting handles, moving them around, re-embedding them. And ultimately, you turn this part into a decomposition problem. The second part is a second decomposition argument. I mean, the whole point is you want to understand this and this, and you come up with a common quotient. And to show that this and this are the same, you have a decomposition here that has to be shrunk, a decomposition here that has to be shrunk. And these are two independent arguments. You could think about either one first, the other second. So the first night he gets up and talks about the first one. And this was the longer one in the paper. This is in the sections 2 or whatever through 8. And this is very hard to talk about in an hour in any sensible way. And it wasn't yet completely formulated. And I think it's fair to say that this talk was all over the map, probably as far as most people were concerned in the audience. I mean, he was invoking a lot of mathematics, in particular surf theory. I should say here, by the way, I wish I had some documentation, and there is documentation of all this. On Friday, I decided to see if I could find these old notes of Mike that he sent me, these 15 or so handwritten pages. And I went into my shed, which is completely packed with junk, about half of it mathematics, and started piling through some of the math. And I made headway, but didn't get anywhere near close. I did get to the 1970 section and started discovering some old seminar notes, which slowed me down reading them. Old letters of recommendation I'd written, which slowed me down reading them. But I didn't find these notes, and maybe someday I will. As far as notes from the lectures that Mike gave at San Diego, Rick has wonderful notes that he took there that he showed me last year when I passed through Milwaukee and visited him. And unfortunately, Rick didn't bring them. I didn't remind him to bring them to this conference, because they give a good idea of what a bold assertion these seminars were represented. Okay, so after the first night, well, okay, I mean, we have something to think about here. There was developed, I forget when we started, probably every day that week, lunchtime seminar at the picnic table outside the math department. And so once Mike got up, made his announcement official, we intensified our efforts there. And this was great. Mike was out there, 3, 4, 5, 6 of us, and we asked him questions, raise our objections. How do you handle this? And, you know, his answer would maybe change a little bit, and think about that, and whatever. I mean, he was a good moving target, always ahead of us. You know, we were trying to catch him and nail him down, but he was always 1, 2 steps ahead of us. Amazing. So then the next night, he gives a second talk, totally different. And this now was totally out of the blue. I mean, this was a pure shrinking argument, among which probably the world's experts were there in San Diego. And this shrinking argument that he proposed was just totally wacko off the wall. I mean, you look at this the first time and you say, what? Where is this coming from? This can't possibly work. He took a decomposition and tried to shrink it by making it worse. I mean, well, in the end, it turned out to be a philosophy of work. Anyway, to try to keep this chronological. Okay, after the second talk, I remember Bob comes over to me and he says, what is this stuff? Could this possibly work? Actually, we don't know, we're working on it. Okay, so then further developments took place at the lunchtime seminar. And I remember one famous incident there, I think it was on Friday, when things got particularly intense, filling in details. One of the major participants actually almost lost his temper, exploded, and said, Mike, this can't possibly make sense. You can't possibly make this work. That person subsequently, when things worked out, wrote a letter of apology to Mike. And contributed to the argument, in fact. Anyway, there are details here that we should perhaps revisit, whatever, but now I'm just going to wrap this up by sharing what happened to me, to Mike, to the argument in the last 72 hours. Mike persuaded some of us to stay on a little bit. I stayed through some of Saturday. When I left on Saturday to go back, in my mind the situation was like this. Okay, so both halves of the argument now had a plausibility factor that had risen from 0 to something substantial, but there were still things I didn't understand. I didn't understand how the convergence in part 2 was working out, but by now I understood what he was trying to do, the basic structure of the argument. In part 1, I could see that this was leading to some specific decomposition, but once the details of that decomposition were worked out, that decomposition would have to be shrunk. So I went home, and Mike and I stayed in contact. I would call him, how do you handle this? He would feed me what his thoughts were, and then he would call me. What do you think about that? Okay. So it was 3 stages for me. Let's see, first, sometime on Saturday, I realized that in part 1, he really could reduce what he was trying to do to a concrete decomposition. There really was a concrete decomposition that emerged there. Okay, so by then you say, wow, okay, this guy is onto something. Sunday morning I decided to think about part 2. Does this crazy argument he proposes converge? Is this working? And by the afternoon I could see it did. We talked, Mike knew it did. And he just knew it did. I told him I now believed him that it did. Okay. So all that remained then, as of Sunday night, was to go back and shrink this very specific decomposition that he had come up with in part 1. And that I thought about, and I said, look, this isn't like anything I've ever seen, but it involves parts of what I've seen from about 3 different directions. And some of it, I just thought about this, and I said, wait, all you have to do is shrink it in the logical order specified by the parts. And that was it. And that became, I guess, the argument in section 8. Okay. Now, my final understanding didn't happen until late at night, so I didn't call Mike. Mike calls in the morning, and we talked about it, and I said, you have a theory. Congratulations. Wow. So, one comment there is, I've always felt sort of privileged to have been the one person who knew this argument for 12 hours before anybody else in the world who knew all the details of this argument. By the way, this is just the cat's and hand with his homework with the standard. This is not the Poincare conjecture. The Poincare conjecture part of it didn't emerge until, I don't know, whatever it was, weeks or days or weeks later, and that's where Frank played a fundamental role. That's section 10 of the paper. Yeah. Okay, there was another comment I was going to make, and that was about how this related to Donaldson. So let me make this now. This is a sort of retrospective comment, but I've sometimes wondered what would have happened had the timetable been a bit different and had Donaldson come before Freedman. So we know that the combination of Donaldson and Freedman is that there are topological manifolds which are not smoothable. For example, that one with index 16 that you get from the K3 surface. Donaldson showed that there couldn't be a smooth manifold with that homotopy type. Mike showed that there was a topological manifold with that homotopy type. 2 independent things. Now, the point of Donaldson's work is that he showed that Casson handles, as a corollary of his work, could not be smoothly standard. So corollary of Donaldson, of course, 1982, Casson handles cannot be smoothly standard. Now, on the other hand, had Mike attempted to shrink his part 2 decomposition by classical techniques, because classical shrinking arguments are smooth pseudo-isotopies until the last instant. Every classical, and there are a million shrinking argument that had existed until 1981 was by a bare hands shrinking that was a smooth pseudo-isotopy until the last instant. And it's a corollary, if you could shrink part 2 via that sort of pseudo-isotopy, that would in fact show that Cass and handles are smoothly standard. So the point is, had Donaldson done his work first, we shrinking people would have said to Mike, wait, I mean, there's no way you're going to shrink that part 2 decomposition because that would show that Cass and handles are smoothly standard, and they're not. But Donaldson came later. That didn't happen. But I've always thought it would be interesting if time had gone the other way. Now, knowing Mike, of course, he wouldn't have let Donaldson stand in his way. He was going ahead and come up with his part 2 argument anyway. Okay, I think I've said enough. If anybody else relinquish the microphone.
I had the privilege to be a sounding board, I think, for some of Mike's ideas, but my memory isn't what it used to be, so if I screw things up, I hope you'll set them straight. But before I ever knew Mike, I must have seen a copy of the S3 Cross R paper, and at that time I was at the University of Oklahoma, where a wealthy oil man named Herman Karcher had created a fund that allowed us to invite people in for extended periods of time. So I sought out Mike, I think at this AMS meeting you referred to, I think that's where it took place. Were you the speaker there?
I don't think so.
Well, anyway, you were there though, right? Yeah, I found you there, and I asked you if you wanted to do this. And my impression was that you said, well, I haven't been thinking about Cass and handles much recently. Is that possible?
It's possible.
Yeah, but you agreed to. Yeah, you agreed to do it, and so then I forgot how much time went by. You came to Oklahoma. I don't remember your talks at Oklahoma. The only thing I remember about that is when you were there was a dust storm. So that if you'd gone outside in the dust storm, you would have looked like a member of the Blue Man Group, except you would have been red. But anyway, then the next thing I recall is that before this meeting where Dennis Sullivan was the principal speaker in August, you invited me to visit you at your house in Del Mar there, and I went there and you explained to me, what your ideas were at the time, and so I remember, starting to get a picture of how Cass and handles could be, turned into decomposition, described in terms of decomposition spaces. And I was sort of an expert on decomposition spaces, in fact, and then your talks occurred at this meeting that Bob's referred to. And in my mind, at the time, I found the description of Cass and handles in terms of decompositions and the hope for final argument really plausible, but there was this one other item, which was this sort of approximating this map between four spheres by homeomorphism that I didn't understand. And let me just give a little more context for that. So this was something that would have been known in all dimensions except four. The person who did the three-dimensional version is in the audience, Steve Armentrout, and then the five-dimensional version of this thing is Freedman. But there were no tools in dimension 4 to do this, and the description I remember from the conference involves some application of surf theory, and I found it, just mysterious. I didn't get it at all. And then there was this outdoor conversation where a number of us, including Bob and probably the other living expert on decomposition spaces, were in the sitting there, and the other guy decided to give you a little lecture about why it would never work, which you suitably ignored. And then a few days later, I went back home after the meeting ended, and a few days later I got a description of the final argument in the mail. I actually have a copy of that here. It's this handwritten. Yeah, Mike's handwritten thing. So I understood this immediately because it was so close to things I knew, and I wrote a little exposition of it, which I circulated to a few people, and it kind of spread out. And but it was, thanks for allowing me to be your sounding board.
I do remember that I was kind of discouraged. It was very helpful that you invited me to give those lectures because I had set the whole thing aside. Part of the problem, I was kind of down this long alley, and there weren't too many people in the world who wanted to hear about the latest twists and turns. There was Bob Edwards, and I think Bob would listen politely to me, but I was in Southern California, and he wasn't coming up to Berkeley that often. So there was really only, as far as I knew, until then, only Bob Edwards was the only person in the world who cared about it.
Well, we had some correspondence, but we couldn't really talk.
We could talk about it, yeah. It was too, it somehow too pictorial somehow. But anyway, that was, I'd completely forgotten that it was sort of on the back burner maybe for 6 months. You asked me to come. And then I remember preparing the lectures I gave. It was very helpful, coming back and actually kind of nailing down my understanding of things that Casson knew from the very start.
Yeah, well, you can thank Herman Karcher. Last night I was trying to figure out exactly when that occurred, and I went online to the University of Oklahoma website, and I couldn't, there's no record of it that I could uncover there. But maybe it's, it hasn't been computerized. Anyway, thanks a lot.
So I remember Mike mentioning this talk at Oklahoma and how it sort of restarted his program. And so I went to this meeting also that starred Sullivan. One of the things I remember from it is Rob mentioned there was videotape, that one evening we were watching some of the videotape Sullivan was watching, and he sort of giggled at one point and says, "She's right, you can tell when I'm lying." So anyway, well, I've been working with Mike along some of these lines earlier, exploring some of the consequences of the intermediate version where you could re-embed inside, and I spent a fair amount of time with the re-embedding technology. So I got there, and there was this fabulous argument. I guess I should say there are two problems with doing something like proving the Poincare conjecture. And the first problem is doing it, and the second problem is getting anyone to believe you. And the history on the second one is not so good. So other people have tried it, and sort of interesting sociology. If Mike had said, "I have proved this," and then started talking about all the beautiful corollaries that it had, and sort of, we would have said, "No, you haven't." Because the truth was he hadn't proved it. But he didn't say that. He said, I think I have these ideas that might converge, and let's think about them jointly. So instead of saying, "I have proved this theorem," and successful. You might contrast that with Colin Rourke's announcement of the proof of the three-dimensional Poincare conjecture when he held a news conference to make this announcement. That went over very poorly, and it made it adversarial, and the sort of expert community didn't really think that it was likely, but they didn't want to get involved in some kind of shouting match or something like that, particularly if New York Times reporters were following him around. So he had some trouble getting much of a hearing. And when Perelman announced that he had an outline of a proof, one of the things he did to establish credibility was come to Boston and Princeton to give some lectures, and I happened to be in Princeton for the one there, and he gave an extremely technical lecture about some wonderful property of the Ricci flow and differential equations. Never mentioned the theorem. And people went away saying, wow, this guy really has a deep insight into it, and, we'll take him seriously. So, it was a sort of delicate thing. For a while, I was the editor of the research announcements in the Bulletin back when there were research announcements in the Bulletin. And there were certain things that I wouldn't, as I had a sort of form letter, I wouldn't even consider. I wouldn't send out for any kind of review or anything proofs of certain theorems. It just, you couldn't announce something like that. You had to have a proof. So there's a real credibility problem. And I think if anybody here ever does prove a really big theorem like that, you might think about that don't think about what a great thing you've done, but keep it in the community. Keep it, say, this is something that we can explore together, and we can make sure all the details are right, and so on and so forth. Because the second part, this independent shrink, they alluded to where he proposed to use surf theory. Well, I had spent a lot of time with surf theory, and it seemed quite silly to me. This was not going to work. It was not relevant, in fact, sort of a dynamic move, where you can end up with grammar. So, but, I thought about it for a while, and I figured out how to replace it with a reflection argument. But the way he put it, my goal was not to shoot him down to say, you don't have a proof. I was invited into the process along with Bob and everyone else. And my goal was to say, wow, let's play with this thing and see if we can get it to work. And so it really became a community effort. And that was a really wonderful experience. Let's see, do I want to say anything else? Oh, I guess one thing I would say is, if by any chance any of you people have looked at the book about this stuff, there are lots of pictures. Well, those are pictures that describe what's going on by just drawing a sort of spine of a thing. Mike's pictures were link diagrams, which used the fact that these spines were sort of balls with something cut out or added on or something like that, and you could look at the sort of dual things of the spine and flow them out to the boundary and see it in terms of links on the boundary. So these link diagrams were sort of indirect in their relationship to what was sort of actually going on in the manifold. It was pretty hard to check some of this stuff. And some of them had a lot of dots in them, said things like this, and ramify, and so on and so forth. So I guess there were a lot of points that could have been attacked. But he sort of presented it as sort of community thing, you know. And so a lot of us, quite a few of us, worked on it to see what we could do with it and contribute to it. And I think, well, as I say, it was a wonderful experience. As Bob says, it was a wonderful experience for those of us who did it. I think it's a very constructive way to think about mathematics. That it's not an individual thing so much. That really good mathematics should be, to some degree, a community activity. And stuff doesn't really become mathematics until it has become a community activity. You know, you can write down anything you want, but it's not a proof until somebody reads it who can understand it and says, okay, you know, I follow this, I believe it's correct. Somebody who is qualified to read it. You know, it's not a solitary activity. And, well, anyway, think about that. The sense of community is really important. And that's something that Mike has always contributed to very strongly.
Let's see, there's one more thing we might talk about here, which is an after effect of Mike's work, which is the exotic R4. So, you know, the existence of an exotic smooth structure in R4 was a total surprise. Well, so was Mike's work in the first place, but this was never expected. You know, Stallings had easily proved that Rn for n greater than 4 had a unique PL structure, and that was known in dimensions 3 and less already, so the fact that 4 might be different was really a surprise. So where did that come from? Well, part of it came when Andrew Casson lectured at IHES in spring '74. I've already alluded to that. And Bob Edwards was there, and Larry Sieberman, and I was there, and a few others. And so they talked about, after his lectures, they then talked about it for a while, and Bob already alluded to the fact that it was known that, well, there was this issue of whether the Casson handle was smoothly standard or just topologically standard. And there was some more work was done, I think mainly attributable to Bob, which was known to just a handful of people and not published. So then the next step, so Mike knew about this. So the next step was in March of 1982, when Mike was at IGS and Atiyah came down and gave a lecture on Donaldson's theorem, Donaldson's thesis. And I remember Mike flew back and phoned me and explained that they were explaining Donaldson's thesis, in particular that there were not smooth manifolds with positive definite forms other than the diagonal forms. And the thing I took away from that was that this is crazy. We don't construct 5 manifolds that are 4 manifold bounds as spaces of connections. That was just seemed bizarre to me, but it was, of course, it was very beautiful. But anyway, the other thing that Mike said at that time was there's going to be an exotic R4, and because he knew what was missing for Donaldson was this bit of glue. I mean, Donaldson surely knew of Mike's theorem, the one that's published, but what was Donaldson wouldn't have known about, he wasn't really that kind of a topologist, was this extra bit of glue that, in some sense, Bob and maybe Larry Sieberman and so on had provided at the end of Casson's lectures in 1974. But Mike knew that glue, and that's the glue that was necessary to match up Donaldson's thesis and Mike's work of just a few months earlier. And that's what provided the exotic R4, and so so Mike was the first to know there was an exotic R4. And then what's curious about it all is this amazing theorem is not published as a paper anywhere. There's no such paper with authors. You know, Donaldson wasn't going to do it because he didn't know the glue, and Mike, well, you know, Bob mentioned this, I suppose Mike's work had been done after Donaldson's work. Well, then Mike would have published the exotic R4 as a corollary of his work, but he wasn't going to write a separate paper on his own. So there is no such paper, but the first person to know the theorem was Mike in that way. So.
I think I also knew something that wasn't quite true also at the time. Because I also thought that the existence of exotic acid handles would imply by a violation of the operation of words a different kind of exotic R4. And that was only indicated the next year when Donaldson gave a compact counterexample.
Well, that was
So I had some different R4s floating around.
that's a corollary to what I was saying. I guess I wasn't going to mention that, but you remember, so you told me this argument, and so I went back and gave a talk in a seminar, wrote down a construction, no, actually, the details of what I thought you had told me. And then probably a year later, we were in the tea room in Berkeley, and maybe you remarked that the exotic R4 embeds in S4. And I said, no, it doesn't. And after a few rounds of that, we began to compare arguments. And you, as you just said, you had used that there was a compact counterexample to in Donaldson's work, and that didn't exist yet. And Donaldson proved it shortly, but you used that, and I used what he had proved, and so we had different exotic R4s in mind. Yeah, so yeah, that's curious. Incidentally, other people who were involved, Jim Cannon is the person who keeps not being named, but he was there in fall. In August '81, and was certainly involved. And Larry Seaman also played a role and was involved in that. He was big on these topics. So, unless somebody thinks of something else, I don't have any. Well, Mike, do you have anything you want to say about those times?
Well, I was just thinking.
Do you want to come up or not?
Oh, sure.
You can be a little better heard if you're up here.
Yeah, listening to the presentations, I was reminded that the proof, even in the published version, is pretty sketchy. The original proof did have a lot of ingredients that turned out to be extraneous. Like I think I wanted to use Hatcher's theorem at some point because that was such a good theorem, the Smail conjecture. I didn't want to leave it out. I wanted to kind of use it to, get some re-gluings, I think, in that second part of the argument, just so. But it turns out it didn't matter whether they were just so or not. But so there were all kinds of loose ends and misconceptions. I think it wasn't so much that the argument, there was a lack of arguments. I think that it was just that a good fraction of the arguments were wrong. I used some expert advice to detect those. There were some missing arguments too, but I think it was more removing erroneous arguments that was important. But that experience made me extremely sympathetic to Perlman because even though there was a lot of discussion from certain areas in the mathematical community which don't need to be delineated precisely, about the weaknesses of Perlman's exposition. It struck me that being an analytical argument, he was being held to a standard that topologists never would be held to. That when an analyst sketches his proof, that's sort of the final form in geometric topology. You don't have a mechanism for writing out the Taylor expansion and handling all the terms. I mean, it just isn't the way we conduct business. We get a mental picture and we put in kind of signposts and details. And I mean, maybe some people do write exact formulas for shrinks and things. I mean, I remember reading some paper of Hollis, but I find that when these arguments are reduced to precise formulas, I can't make any sense of them. So it doesn't do me any good. I mean, maybe there's a machine that will be built one day that can take a precise argument and check it. But the argument for me in geometric topology has to be kind of intuitive. For me to have any chance of telling if it's right, I mean, if it's kind kind of a sequence of formulas, and I'm not very good at checking it. But if it's a sequence of pictures, then I have a chance of spotting something wrong. So I think even the final version, and the version in the book with Frank, is probably at least as vague as Perlman's exposition, I suppose. I mean, I'm not doubting that it's right. I think it's right. But these other gentlemen do too. Much bigger. Okay.
Remember John Morgan told me, he wrote a couple of books on Perelman's work, and his description of it was you came to a sentence, one sentence, and then you started thinking about it. Was it true? Was it not true? How am I going to prove this? And after about a week, you figure out a proof that takes some number of pages. And then you say to yourself, suppose I wanted to boil that number of pages down to one sentence. Well, that's about what Perelman wrote. But I never tried to read Mike's paper, but what I remember is Bob Edwards giving a series of lectures in Austin, Texas, probably in October or November, a month or two later. And when Bob finished, I thought the proof was crystal clear. It was beautiful. So I learned it from Bob, who somehow digested it from your eye. So I don't know personally how clear your paper was, except it was amazing it was written as fast as it was. And but no, I don't think there's any comparison between what you did and what Perelman did.
But I thought Mike gave the lectures in Austin.
You gave one.
Okay.
Maybe yours was the clear lecture.
I actually thought you gave more than one, but maybe not. Yeah.
Well, we were giving long lectures.
Yeah.
I remember I was bruising my feet.
Yeah, let me finish off with this comment. I've always thought that, there's Fields-Metals theorems and there's Fields-Metals theorems. And, lots of them wonderful theorems are nonetheless things that I think would have been done within a year or two or three. Smale's H-coordinate theorem, Wallace was working in the same area, and I wouldn't be surprised that if Smale hadn't done it, somebody else would have within a couple of years. I think the Atiyah-Singer index theorem was somewhat in the air because Hertzebrook was doing stuff like that. And, probably would have taken a while longer for Veit Thompson, probably would have taken maybe a while longer for Hironaka. But my guess is if Mike hadn't done what he did in 1981, it still wouldn't be done. It was just too unlikely, well, maybe I'm wrong, but that's my candidate. You agree? Yeah. And then the other comment I make was it's the single most beautiful piece of mathematics I know. Stop with that. So,